Good afternoon. I'm not sure if this function. Yeah, thank you. So, I would like welcome you to section 1, which is about production of forages and fermentation process of silages. My name is Filip Jančík and I am from Institute of Animal Science in Prague, and I will be here with my colleague Professor Skladanka, which is from Mandl University, Brno. And now I think we can start with first presentation, and it is here, and first is Professor Resch. Yeah. So there.
Thank you, Mr. Speaker, and it's a great pleasure for me to see you all in presence after a long period of a high amount of online meetings. Yeah? It's nice to present you a topic of biorefining. I want to speak about re-ensiling of pressed cakes with different materials. So let's start. We did a multi-disciplinary project with lead partner of Dublin, and this was amazing to work on such different questions and in this biorefining topics. So this was a live project action C5.1 where I was working for. Climate change effects are occurring. So we see sometimes in yielding or also in quality questions, this affects daily. Yeah? And we have a need for sustainable feed production and food production, and in governmental strategies, yeah, protein self-sufficiency is much more important than in a few years ago. It's growing in importance. Production of protein feed not only for ruminants, also for monogastric, like broilers or swine in fattening, yeah, is in concurrence to human. And so we look for strategies where we can supplement protein from other sources. Biorefinery is a way where we can get material that is preferred for ruminants, yeah? And in the past, it was not usable source for monogastric. So we get some material like a smoothie, yeah, for chicken and swine. And I want to tell you in this presentation about the ruminant way where we can use the residuals from the biorefinery. So what do? We put some grass silage in bales and have different material of Upper Austria, like grass, a mixture of red clover and grass, and red clover alone. The bale's weight was between 900 and 1,100 kilograms. The biorefinery we did was in 2 campaigns. one in September of 2020 and one of July in 21. The scaling of biomass was important for us to get data or for the balances we determined. Yeah? Important point of view was the watering of the silage we have in different types of dry matter. We see from experiences, maybe from Marketa, Rinne or other scientists, that the process of pressing such material is better if you have enough water in the material. So we prefer 23% of dry matter, and we, after watering the silages, we determine the dry matter content by microwave method. Shredding of silages was in a mixing wagon. We produce 4 round bales such as a replication for analyzing all the effects. A screw press, the type you can see on the screen, was used, and we have, after pressing, a press cake what we re-ensiled in 60-liter plastic barrels. Approximately 45 kilograms of fresh matter was re-ensiled. For each bale we tested out, we use 4 such plastic barrels also as a replication. Fermentation was done, and we have average compaction of 275 to 281 dry matter per cubic meter. It was very good. The fermentation period was 52 to 62 days by room temperature of 20 degrees. The barrel opening was after this campaigns, and before we opened, we scale the weight of the barrels and take samples by a probe cylinder, and we have to conserve the samples by rapid cooling. Chemical analysis was according to Vaudelufa analysis methods, wet chemistry methods, and we did also statistics with package. A few pictures that show you the process of biorefining. We have the material that we pressed in round bales, and after we gave it in a mixing wagon and came the processing of biorefinery with this screw press. Therefore, we get pressed juice. This pressed juice, I called it smoothie, yeah, is for broilers and or swine. Yeah? And my topic that I present is the press cake. You see here the compaction in the barrels. So I come to the results. First, I want to show you dry matter and also protein results. Here you can see the absolute contents in the silage before we press it. We have dry matter contents between 25 to 42%. Then we water it to 23, I said it before, and after pressing, we have exact the same dry matter content of 37%. Yeah? On the right side, you can see the relative changes from silage before and after pressing. Yeah. It's in dependence on the source that you have from the origin, and then you see the changes. The changes in the crude protein are very high. So you can see 135 grams to 158, and after pressing you lose 30 grams. Yeah? In percentage, it's 20 to 25% that you transfer in the juice. Yeah? I know the paper of Marketa Rinne. She said the transfer rate best in screw pressing is nearly 40% of protein you can transfer. We have 35%, yeah? Not so good as the Finnish one. So, also interesting is ammonia, or the ammonia content of total nitrogen. We have not the best situation because the recommendation is less 8%. Yeah? A bit of protein degression. Yeah? But if you look to the results in the pressed cake, the re-ensiled, some parts of the nitrogen also from ammonia is transferred to the juice, and you have in the pressed cake better conditions in ammonia content. Yeah? Next one, fiber contents. It's very interesting to see what does happen when you press some fiber material, because fiber isn't transferred in the juice, or only a little bit of fiber, and this is filtrated. Yeah? We have NDF contents between 340 to 500, and after pressing and re-ensiling, you have 100 grams more of NDF. Yeah? High increasement of fiber in the press cake. Yeah, this will be interesting. Where do you use such a material in nutrition? Also interesting for you is the content of ADF. And you can see also increasing of 100 grams. And that's really important, because high or not high valuable fiber is increasing pretty well. Yeah? In lignin, you have also 8 grams more in the press cake. Yeah? We heard today values from 3 to 4%. Yeah, you have the results here. Non-fiber carbohydrates. If you look to the sugar in the origin silage, after the fermentation, we have nearly 9% or 4% of sugar. After re-ensiling, sugar has nearly gone. Yeah? And we have to look in the next slides what does happen in fermentation. Yeah? There we can see the NFC, the non-fiber carbohydrates, from 20 to nearly 50%, a decreasing is observed. In minerals and ash content, we have a high transfer rate from some minerals, not all of the minerals. Yeah? For example, 25 to nearly 30% of total ash content is in the residues from press cake that we can say 25 to 30% transferred to the juice. This is a high amount of minerals. And now we can see phosphorus, for example. We have contents that are in average for Austrian conditions, 3 grams, and only the half of phosphor you can find in the residues of the re-ensiled press cake. Yeah? It's a high transfer rate of phosphorus and lower transfer from calcium, for example. Also, interesting transfer from iron. Yeah? We have increasing of iron in the press cake, and that's finally an interesting aspect of mobility of different minerals, yeah, to the juice. In questions of fermentation, if we look to the pH value we have in the original, not the best fermentation. Yeah? The critical pH value was not declined. And if we look to the solid fraction, after pressing, this fresh press cake is near the line of the critical pH value. So we can say the acid content of the solid fraction is not too bad. Yeah? And look to the solid fraction after re-ensiling. We have an increasing amount of acids, so we get a lower pH value from all the different material we re-ensiled. What does happen? In the fresh silage we opened, we have, maybe I should say, everything's in order with the different volatile organic acids. Yeah? The composition is pretty good for Austrian relations. Yeah? And after pressing, a high amount of acids go into the juice. And you have a little rest in the fresh press cake, but after re-ensiling, you have a totally high amount of lactic acid, so the fermentation is going on with a low amount of sugar. Remember that what I tell you in the table. So I come to the conclusions. We have big change of nutrients of grass silage due to pressing. We observed an increase of NDF approximately of 10%. Yeah? It's a high amount. A decrease of crude protein between 11 to 24%. A decrease of minerals, 25 to 30%. A decrease of sugar by 50%. And a decrease of fermentation products, 55 to 57%. So you see the transfer via pressing such a material is very different. the fermentation quality of re-ensiled press cakes. Yeah? We opened that, and we have high temperature in every campaign, so more than 25 degrees. And there are hours of between the pressing and the re-ensiling. And the effect was not spoiling of the material, but a re-fermentation, you should say. Significant lactic acid fermentation after successful ensilation. And for me, a very interesting result is the mobilization of fermentable carbohydrates of the NFC fraction. Yeah? No spoilage of the solid fraction due to air contact and high temperature, as said. Very good stability was also observed from the press cakes that we re-ensiled. So, I thank you very much for your attention, and if you have questions, let's go.
So, thank you for your presentation. There is question first, I think.
Thank you. My question, can you explain why you firstly ensiling, after that pressing, and what reason maybe better we did in our country, to press green mass, green grass, after that to ensiling this cake from fresh grass. What reason? I can't understood why to press. It's big, expensive can be to produce silage of that pressing and then sealing again. What reason?
What is the reason?
Yes.
We want to conserve it because we can't feed it to ruminants in larger plants. Yeah? This was only a small scaling in the trial. If you look to larger plants and you process larger masses of fresh grass or ensiled fermented forage, yeah, you need a system, or you have to utilize this material by ruminants or in a biogas plant. Yeah. If you have a biogas plant, maybe you can feed this in with larger amounts of this press cake. Yeah? It is possible. In Austria, we have the way that we want to sell this material or bring it back in a circle of the farmers. They give the silage to the plant. Yeah? And this is a question what we want to bring it back in the agricultural circle.
So, next question was there.
Okay.
Yeah.
So, Stanislav, Hejduk is my name. So, Reinhard, I'd like to ask you maybe, is it possible to feed the cakes, silage cakes, again to animals with low milk yield, probably not, but a beef cattle or some other type of cattle? This is the first part of the question, and the second is how you use the liquid part with the available nutrients. How you use it after the pressing?
Yeah. Our goal in utilization of the press cake is feeding ruminants. Yeah, but if you look to the chemical composition I showed you in the slides, you see you cannot utilize it in high-yielding cows, for example. Only if you want to supplement straw, for example, as a fiber content. It makes sense also for high-yielding cows. Yeah? Otherwise, you can use it especially for dry cows or for horses also. And the question of utilizing the juice, you have to conserve this kind of juice because the juice is highly spoilable. Yeah? You have one way, that is the Danish way, I think. They froze it very, very close to the biorefinery process, or you take energy in the material and put the water away. Yeah? So you have a syrup of high concentrate protein and other nutrients that you can give in a concentrate feed to supplement protein, yeah, from soybean meal, for example. What I don't say or did not say in my presentation is we did also experiments in this project of nutrition of broilers, also of ruminants. Yeah.
Okay, so when you put the grass or silage through the screw press, so also the fiber part is somehow disturbed and fractioned, and there it has been hypothesized, presented that then it should be better digestible for ruminants. What do you think? Is it going to help?
Yeah, that's a very good question, Marketa, thank you. And this, we have exact trials from mutton to get results for the digestibility, and therefore we get some results back that the NDF digestibility is a bit better if you have the processing with the screw press, because the high pressure, the hypothesis we did was you have a crack effect on the strength of carbohydrates, cellulose and so on, and we could see a little effect of that. The utilization in a diet for ruminants was not too bad. And you have not a depression if you have 30% of this material as a supplementation of a normal silage. You have not a depression in feed intake. And maybe this is an interesting result and gives farmers hope that they have not the worst material if it comes back from the biorefinery. So you should say there are good aspects in some questions, yeah?
Thank you very much. I didn't see other questions. Thank you, Reinhard. Thank you for a very interesting topic. And next speaker is my colleague from Mandl University in Brno, Dr. Hejduk, with topic Effect of Permanent Grassland Renovation on Forage Production and Quality and Botanical Composition. Stand.
Fine. Good afternoon. I will continue a little bit with the topic of the permanent grassland, as you can see. And maybe you remember the information from my colleague Ivana Koláčková in the morning, that she said that we have increased the area of the permanent grassland in our country, in the Czech Republic, by about 20–25% since 1990. But on the other hand, the number of cattle decreased by more than 50%. So now we have a trouble that we have not enough cattle to consume all the grassland. The result is that farmers very often didn't use properly grasslands because they use it mostly as a source of subsidies, didn't use any fertilizing, massively used some agri-environmental programs or schemes, and most of the grasslands, permanent grasslands in our country was degraded from the point of view of forage production and quality. Today, I think that the permanent grasslands are the huge reserve of Czech agriculture because it's underutilized, and many farmers are aware of quite high prices of land and want to use the land more efficiently. So many farmers, especially after dry years, started to renovate their degraded grasslands. You can see the picture from one farm when they have production quality forage and they decided to spray it by glyphosate, as you can see, plow it down and reestablish it with a new mixture. Grasslands are a little bit specific culture when we compare it with arabland because from historical point of view, grasslands we can find mostly on the shallow stony dry or wet soils where the cropping is not very profitable or not possible. And furthermore, today grasslands are known as a very important source of ecosystem services. So you know that the grasslands can protect the soil very good against the soil erosion. They reduce the risk of flooding, especially the flash flooding. They support pollinators, and biodiversity is the highest from all ecosystems we have in Europe. Also today is a very important role of grasslands to sequester and keep the carbon in the soil, and also they have some recreation function, as you can see. So in future agriculture, I think their role will be even more important than today, and we need to use it more effectively than we use it now. The research I would like to present here started at this meadow 5 years ago after a couple of very dry years, very dry and hot years. And this is picture from White Carpathians on the boundary between Czech Republic and Moravia and Slovakia. And you can see that some farmers had big troubles with forage production and also quality. This is the picture from the meadow from protected area where they found only very, very low yield, just less than 1 ton of dry matter per hectare. And of course, you can see very poor quality of forage, even for beef cattle is not good enough. The problem was that these meadows, or this meadow was located in protected area, and there is a ban of fertilizing. They couldn't renovate the swards, and also because they didn't use the fertilizing, the nutrient reserve declined to very low level, which was not enough for cultivated high quality grasses and legumes. So it was big discussion, sometimes with very high blood pressure between farmers and protectionists. And the result was that they have not enough results from this area, how the results would be after the renovation, if really the yield would be rapidly increased and also the quality. So you can see some another examples from this area. This is not a dry meadow, but completely yellow meadow. It's maybe a nice picture for people from the cities for recreation, but not for farmers. So in this case, also the quality and the yield is very low. This is maybe more typical picture from our country that this these grasslands are dominated with red fescue. This is very persistent grass, but very low yielding, and it produces also very low quality forage. And it's not easy to overseed it because it's very tough grass. And the last picture shows the dandelion pasture. And if you know this plant, it looks nice, of course, but from the point of view forage yield, it's very, very low yielding species. Yes? So in this case, the only way how to improve it is renovate this grassland. Okay, so why we use renovation? Of course, I mentioned already that we need higher yields and better quality. And usually we decide to renovate the grassland if we find there less than 50% of desired species. Sometimes we can use just improved fertilizing system or use overseeding, but in some cases, especially in the case of red fescue, it's not enough because red fescue, once it dominates grassland, it's not easy to overcompete it. When we think about the species which are used, or the mixtures used for renovation, is the big question for farmers. Usually we use just a mix of grasses and legumes. It means from grasses we prefer perennial ryegrass, timothy, meadow fescue. In our country, Festuloriums are very popular. But legumes are even more important because they can fix nitrogen and produce very valuable forage. Especially red clover is, I think, #1 for the renovation of permanent grassland in our country. In last 10 years, we also start to use some forbs, especially those two species, chicory and plantain, which were bred in New Zealand, especially for pastures, for grazing. They are also offered in our country, but they are still not so common. Okay, what we want from this species in the mixture? The first one, I think, is the nitrogen fixation. You remember maybe last year when we had very high prices of fertilizers. 1 kilogram of nitrogen cost about €3, almost €3. Today is a little bit less than €2, but still it's quite expensive. So the legumes can fix the nitrogen without any income. We also need plants with deeper rooting because, as you know, climate change is linked with higher temperatures and higher evapotranspiration. So drought tolerance is a very important trait of all forages. Also, deep rooting improves carbon sequestration, and maybe it can be some source of income for farmers in the near future, because there are some payments from other companies which are willing to pay farmers for storing carbon in the soil. And also, maybe the first one should be the increasing forage quality when we renovate grasslands. Usually the forage quality is the most important result from this. Okay, so the final result should be lower forage cost for farmers. Okay, unfortunately there are some drawbacks and risks which are linked with permanent grassland renovations, especially when we use the tilling. The first are the high cost. We calculate the cost about €1,000 per 1 hectare, so it's not really cheap. The soil tillage costs something, machinery, diesel and seeds, they are the most important cost for the renovations. The second problem is very rapid mineralization of soil organic matter after the tillage, which release plenty of carbon dioxide to the atmosphere, and also it lowers the capacity of the soil to store water and nutrients, what in the result is decreasing soil fertility. In some cases, we can find a problem with the nitrate leaching. The nitrate concentration in some cases can increase above the limit for the potable water. And also the nitrification means the losses of nitrogen, what is costly for us because nitrogen is quite expensive nutrient. In protected areas, usually the renovation is limited or totally banned to avoid the loss of protected plants. So you can't use renovation whenever you want. And there's the last trouble on the less fertile soils. It's not, the costs are not always covered by higher production and quality. Yeah? So you need to choose some suitable soils or suitable fields for these renovations. Okay, concerning to our trial, we established two trials, two experiments on the White Carpathians. The first was in the area of village Lipov. It's quite dry, warm area when the vineyards are common, and they are quite heavy soil with this advantage for storage of water and nutrients. The farmer decided to use the summer renovation, and it was conventional farm, so the farmer was able to use some mineral nitrogen. I recommend him to use the mixture, seed mixture with 10 species, for legumes, 6 grasses, standard sowing rate about 32 kilos per hectare, and he applied just 55 kilogram of mineral nitrogen in harvest years, so it's quite standard. The second site was in Popov, an organic farm, quite large organic farm with dairy cows, and they decided to use two different mixes for renovation. The first was standard mixed with 9 species, 4 legumes, 5 grasses. Sowing rate was a little bit bigger because they use also the Senfoin onobrichis, which has larger seeds. And the second one was the mixture from botanists from protected area, which was very expensive. 1 kilogram cost more than 40 euros, so much more than standard mix. And it contained 22 autochthonous species from this area, 5 grasses, some legumes and forbs, and the seeding rate was much lower because of the very high price. And of course no fertilizers were applied because it was organic farm and protected area. Okay, here in the picture you can see the first farm, the Lipov, with the owner. And you can see originally it was the large field, about 15 hectares of permanent grassland with quite low production of hay. And he decided to divide the field on the two halves. The upper half was not overseeded but renewed, and the bottom part he needed to left because it was the risk of erosion for the village. So 1 year or 2 years, sorry, in the second harvest year we sampled the swards just 4 or 6 meters. We decided to take the areas for sampling which are not far away from the renovated and original sward. So this picture is from original sward. So you can see the yield is not really very high. The diversity was quite good. When we compare it with renovated sward, you can see completely different situation. So the sward was very tall, very productive, and from the 10 species we seeded, only 2 won. It was tall oat grass, Arenaterum latius, and the second was cocksfoot, Dactylis glomerata. So they were 99% of the biomass were only from these 2 species. So here you can see the result. So the dry matter yield was increased twice by renovation, so it was very successful. Crude protein was a little bit higher, but not so much. And you can see very low value for dairy cattle is very low. So the forage was used for horses. So in this case, it's enough. NDF was much higher for renovation. The reason was that these aggressive, very productive grasses needed to be harvested much earlier compared to original sward. Also, the lignin was a little bit increased, but not significantly different. And crude fiber was also increased after renovation. Yeah? So you can see clearly that renovated swards needed to be harvested earlier. What surprised me that export of nutrients was very high, especially on the renewed sward. As I told you, the fertilizing was just 55 kilograms of nitrogen, and it was exported 3 times more. So the rest of the nitrogen came from the mineralization of organic matter. And also the potassium was exported in the largest amount. Yeah? So you needed also increased fertilizing after renovation of grasslands. From the botanist point of view, it was quite sad situation because on the renewed grassland we could find just 8 species, but the 2 were dominant, and on original sward was situation much better. So the botanists wouldn't be very happy with this result. Okay, so this is very important when we use the productive species as a cox food is they usually have more water in the leaf, so leaf dry matter content is lower than in the native wild species. They have larger specific leaf area, it means the leaves are thinner. They have very high digestibility and high proportion of leaves in vegetative state than wild species, but just if they have enough water and nutrients. On the other hand, they need to be harvested earlier, as I told you, because they started to be very mature in this flowering stage. The second experiment on the organic farm was done in this village Popov. As you can see, clearly you can see the big effect of the renovation on the dandelion presence. So you can see there are some dandelions, but much less than in the original sward. Here you can see. The second unwanted result was that after the tillage of the soil, we activated the seed bank of the docks, Rumex optusfolius, and I was really surprised that there were so huge amount of seeds in the soil. So after the plowing and tillage, they were activated and made a big troubles. Fortunately, after 3 years, they slowly disappeared, and now it's much better. So it's another risk of the renovation that we can have this result. Okay, so the results from the second site, you can see that we use the original grassland as a check, as a control, renewed mix with the standard mixture and renewed with the species-rich mixture, which was very expensive, as I told you. So the dry matter yield was again increased by the standard mixture, but not by species-rich mixture. So from the farmer's point of view, it's not very interesting result. It's just from the first growth, so the total yield would be bigger because unfortunately they had not enough forage and they grazed the second growth, so we were not able to sample the second growth. Anyway, the number of species was a little bit decreased by renovation by standard mixture, but increased by the species-rich mixture, so you can see very high numbers of species. From the quality point of view, again, you can see very lower proportion of crude protein, a little bit higher on original grassland due to high proportion of white clover. NDF again was higher, much higher than on the original sward because they were the early species which matured very quickly. And the same was okay, it was a little bit different for lignin. Lignin was increased by this species-rich mixture because there were some not very high quality species. It was the result. So very successful was this daisy. Daisy was very current in this species-rich mixture. Also the Salvia pratensis and Centaureacea were quite common in this mixture. Okay, here you can see again the mixture. The daisies are very visible. This is original sward, and this is the renovated, which is much higher. Okay, so going to the end, just I would like to emphasize the importance of permanent grasslands for keeping carbon in the soil underground. And after the tillage, you disturb the soil structure, what means also decrease the soil fertility. And I found also some source in the literature from Ireland, despite it was written by Czech authors, these results came from Ireland, and they described that after the plowing the old grasslands, they found a loss up to 30,000 kilograms of carbon, which were lost in the first year after the plowing, and it was linked with 3 tons of nitrogen per year. So 3 tons of loss of nitrogen is very high loss, and you can imagine how dangerous it can be for environment. So it's big risk for environment. And I think it's also important for people to know that many people blame farmers, cattle farmers, that they have a cattle which produce methane, and it's very dangerous glasshouse gas, of course, what is true. But on the other hand, we need the cattle for keeping the grasslands, because after the plowing of grasslands, you can see that since the beginning of the Industrial Revolution in the half of the 18th century, we lost the same amount of carbon dioxide or carbon from the fossil fuels as it was released from plowing of permanent grasslands. So we need the permanent grasslands to keep the carbon in the soil. Without the cattle, it has no sense to have the grasslands. Yeah? So I think it's important for farmers and also for you to know that. And this is the trial from UK, published by Pete Smith from Aberdeen, that you can see that after the grassing of arable land, you increased rapidly the content of the carbon in the soil, and I think it can be a big challenge for the current farmers. So, just conclusion, the renovation can be a very effective way how to improve forage quality and yield. On the other hand, it's not profitable in all habitats. Usually you need to improve also the soil by liming and fertilizing. You need to harvest the renovated swards earlier than you were used to harvest the original swards, and I would recommend to try to improve your grassland management to minimize the frequency of sward renovation, because it's costly and also it can be risky for environment. And this last picture is again from White Carpathians from the site Chartorie, when we have some trial, and this is the most this is the grassland with the highest recorded biodiversity in Europe. So we need also grasslands for keeping biodiversity, but the forage should be used for feeding of cattle. So thank you, that's all for me.
Thank you for presentation your results. And have you any question?
Maybe I have one question. Stanislas, we have seen a picture of grassland in dry areas. And what do you think about the using of Festuca arundinacea or Festulolium for renovation of grasslands?
Okay, so tall fescue and also festuliums are quite commonly used for renovations, but the trouble is that in this case, in protected area, they hate tall fescue because tall fescue can be very aggressive grass. It produces some allopathics and it reduces the biodiversity. So in this case, it wouldn't be a good idea to add it to the mixture.
Thank you. And we are late, so we can go to next presentation. And Marketa Rinne tell us something about ensiling of red clover. So, please.
Good afternoon, everybody. So now the topic actually is how to improve the fermentation quality of poor red clover. And the means that we used were including grass in the mixture, or having higher dry matter, or using a formic acid-based additive. And well, here is some introduction about the importance of forages. So it's of course good to have perennial plants. All the plants that we can directly use for human consumption are actually annual ones. So forages then provide the opportunity to utilize more effectively solar radiation, because they are already there now in the spring when the annuals have not been seeded yet. They also have large root systems, so then they bring more carbon into the soil. And then if we use forage legumes, then we can also utilize the nitrogen fixation. So we have all these natural ecosystem services in use. Red clover is the most winter hardy forage that we can use in Finland also very well, or best, not too well actually. So it often disappears during the winters, so it may be only up to 1 year, usually 2 years, but then already third year is usually very poor. And so then we got this idea that maybe it would be good to actually grow red clover as a poor culture, because when we grow it together with the grasses, then we need to do a lot of compromises. They have different needs in fertilization. Red clover develops later in the spring, so they have different optimum for harvest time. Also, red clover is not so tolerant for frequent cutting. They have different needs. For plant protection, usually not so much plant protection is needed for forages, but if it is used, then they tolerate different substances. And also, when you have red clover in all your swards, then the diseases become more common. So if you would only have red clover in a field where there was no red clover previously, so then the disease load would be less. And maybe as a result, actually then the red clover would stay there for longer. And also then the harvesting would be at different times, so there would be not so big peaks in the harvesting. And even the ensiling could be optimized for the different types of forages, because the grasses and legumes have different way of drying during the wilting, and maybe different additives could be used for them. But of course there would be also some disadvantages. So if the clover anyway would disappear from the field, then there would be nothing there. So of course that's kind of safety. If you have other species there, they would anyway grow. Or if the red clover is lost only from some parts of the field, then there would be more weeds, which can be harmful also. And of course, then if you would be harvesting more times during the summer, that would increase then somehow the need to be harvesting more frequently. But there could also be some advantages of having these different types of feeds in the farm. Nowadays, when TMR is used, farms are larger, so then if you would have different types of forages available, then you would have more flexibility in doing the TMR recipe, because then you could mix them in the proportions that would be most suitable. And for example, better balance the crude protein content of the diet not to have so much nitrogen, potentially impacting the environment. And with regards to red clover, there's a specific need. It has a very high calcium content, and it's not good for dry cows, so then you could feed the dry cows with a forage which didn't include any red clover. And again, disadvantages as well, so then you would need to have more silos open at the farm, bigger risk for aerobic deterioration, and also more labor to prepare the TMRs when you need to get the feed from several places. But anyway, all these kind of ideas we had, so then of course one thing that needs to work, even if you think of trying something like this, that you need to be able to preserve the poor red clover silage properly. And then in this experiment we had poor swaths of both red clover and Timothy, and then we made mixtures of them on fresh matter basis, so that we had poor red clover or 50-50 mix or poor Timothy. And then we made the silages fresh directly from the field, or then we wilted them. And then we had 2 additive treatments. The other one was no additive, and the other one was a formic acid-based additive. So we had 12 treatments, and we made this in vacuum plastic bags, this experiment. Here's some photos from making the experiment. So actually, here in this corner here, this is the way we wilted. So it was actually a very humid time period when we were making this experiment, and unfortunately there was no flexibility to wait for a better time. So then we artificially wilted the grass inside in this dryer. And here is my colleague Marcia Franco making the vacuum bags. So that was about making the feeds. And here is the raw material concentration, and indeed it was not a very good example of silage making. It was extremely low dry matter in the fresh material, only 11-12% dry matter in both red clover and Timothy. And even after wilting, we didn't get too high. It was 30 in red clover and 25 in Timothy. So for farmers, I would say don't definitely do like this, but of course in experimental setting it's nice to see what happens when you do such things. The buffering capacity was rather low and quite similar in both materials, and water-soluble carbohydrates also rather low in both materials. So in this way the Timothy was not very representative. We would have expected higher sugars in Timothy than in red clover, and higher buffering capacity in red clover than Timothy. So they were quite similar. And also then the fermentation coefficient, it was rather low, showing poor expectations for good silage quality in all materials. Only the higher dry matter Timothy was kind of okay. Also very high crude protein content in both materials. So maybe the only typical things were that in red clover there was more ash, and in Timothy there was more fiber. And then some results. So on the left side is the pH, and the top line shows the fresh non-additive treated silages, very high pH. This was really bad. But you could improve it with all this, not by increasing grass, it didn't work, but by wilting and by adding the formic acid additive, then you could improve the situation. Then on the right side, there is the proportion of ammonia nitrogen in total nitrogen. And again, in the low dry matter, non-additive treated material, it was higher, but it was actually decreased by red clover inclusion, and this could be due to the polyphenol oxidase enzyme that binds with the nitrogen and prevents the degradation. Here is the cumulative presentation of the fermentation products and the water-soluble carbohydrates. Okay, I found the pointer. So, if we start from the water-soluble carbohydrates, there was basically no sugars left in the control low dry matter feeds, and this clearly tells that the production of the acids that could preserve the silages, that was not, because of lack of sugars, there was not enough acids. But then with the formic acid addition, there was still some sugars left, so that the substrate was not limiting the acid production. And then these low dry matter non-additive treat with silages were really, really bad in many ways. This orange part here is acetic acid, so we definitely had a lot of it. And there was also quite a lot of propionic acid. You don't usually get very much of propionic acid by the fermentation, but in this case there was a lot. We talked quite a lot about ethanol earlier this morning. There was in the wet silages some ethanol, but that was not maybe that extreme. So very different types of fermentation based on the treatments, and actually quite big difference here if you look at these very wet silages, which were totally destroyed without additive. With the formic acid-based additive, you could make decent silages even from this material. The difference was not so big in the drier material, but even here the sugars had all gone, which is kind of worrying. So even there, clear benefits from formic acid addition. Then the aerobic stability, this low dry matter non-additive treated silages had a very poor aerobic stability, about 60 hours compared to the rest, where there was not so big differences. But what is the message of this figure is that we all know that acetic acid should be the one that is protecting the silage from heating, and there was huge amount of acetic acid in these silages, and still they were heating. But I think these were so bad in all other ways, the high pH and so on, so that probably contributed. But then also, like this correlation should be the other way around. Now it's going in totally opposite direction that it should go. But then when the results were presented as undissociated acetic acid in grams per kilo fresh matter. So here it was total acetic acid in dry matter. Then it somehow, at least the slope is now to the right direction, but still these feeds here are clearly deviating. So these were really strange silages in that way. So at least then the conclusions we can say clearly don't do like we did, but if you for some reason have really challenging situation for silage making, then formic acid-based additives can help to some extent. And even though we had here not so great silages, I think still even the experience from the practical farms and also from this experiment shows that it's possible to make decent quality silage also from pure red clover. So that is not the reason why you shouldn't do it if you have other good reasons to do it. And it could, for example, be a good raw material for these biorefineries as well because of the high crude protein and low fiber content. And also, yeah, this effluent issue is one if you have such, if you make red clover, pure red clover, I think there is a bigger risk of not being able to prevent the effluent production. But on the other hand, the red clover is quite easily compacted, so it's easier to make it so that the air is not infiltrating into the silo. So this was the results from the experiment, and I still have some ads here now. I want to remind you about more silage meetings coming up. There's the International Silage Conference in Beijing, China this August, and the registration is now open. You can even still submit papers until the end of May. And there is also a possibility for online participation. So keep this in mind. And then in 2 years' time, there's going to be the following International Silage Conference in Florida. So put that also in the back of your minds. So then we can meet again. Thank you.
So thank you for your presentation. There is a question.
Thanks, Makata, for this very interesting presentation. Indeed, very interesting results, especially the unwilted forages. I mean, there was hardly any lactic acid, but much acetic acid and even quite significant concentrations of propionic acid. So I have two questions. I mean, we have heard today that based on the fermentation end products, we hardly have a chance to say, well, which organisms produced those. And I was wondering if you had measured propylene glycol, 1,2-propanediol, and propanol, and did you measure nitrate in the fresh forages?
Yeah, unfortunately, we don't measure these other alcohols that you mentioned in our lab, which is a big disadvantage. And hopefully we will get that sorted out at some point, but I think we had the nitrates analyzed. Yeah, there was 0.2 grams per kilo dry matter in the red clover and 1.1 in the Timothy. So what do you say? Was it low or high or?
Nitrate concentration certainly low, and it is really that you don't Sorry. Well, nitrate concentrations are rather low, of course, and it's really a pity that you don't have the method implemented to analyze alcohols other than ethanol, because, I mean, propanediol and propanol would be parameters that could be used to at least hypothesize if the acetic acid concentration or the acetic acid formation was related to clostridial activity or heterofermentative lactic acid bacteria, of the Buchneri type, of course.
Mm.
Still some question? There.
Okay, so I was surprised that there was the same level of crude protein in the grass and in the red clover. So how you can explain it? Because red clover should have more crude protein than grass.
Yeah, of course, this grass was fertilized with mineral fertilizer, so that doesn't really make it even, but it was higher than what we expected.
But the level was not very high, because we are used about 18% of the crude protein in the dry matter of red clover, but you had much lower values, so maybe it was matured red clover. It can be maybe the
Actually, it
explanation.
was higher than that. It was
using crop advent annuals can increase dry matter yield per hectare and can decrease and to reduce losses of some nutrients. And one of them, it's what we tested, is winteria. Test materials and objective, we try to investigate some inoculants. You can, I do not tell about that because you can read yourself, okay? And to the 3 blends of common lactic acid bacteria as an additive. This was been produced at Copani Kristian K. No. Laboratory silage was been made. Early cut, 2 stages of maturity in early cut boot stage or soft duff stage of grain. We produce a silage in mini silos and was chopped prior to ensiling and separated into 4 pills and treated and or not treated. And for each treatment, 5 replications, 5 for chemical and microbial analysis and 5 for aerobic stability test. Analysis, fresh forage was analyzed, silages was analyzed and tested aerobic stability. And some results at the end of aerobic stability test. Results. I am all time thinking in what way to place this characteristic forage before ensiling, in material methods or in results. It's, as you mentioned, early cut was been slightly wilted. Dry matter corrected for volatiles was being tested. You can see results. This you can look again what you use it. Decrease dry matter was all additives, of course. After that, fermentation, some results you can see was being decreased ammonia and concentration, is this acidity, some differences was been found, and alcohols too affected these additives. I would like to be shorter because I know that after dinner it's difficult to listen and I don't like to describe all figures, okay? And some variations in microbial composition. If clearly we can see that was being a good effect usage of these inoculants, especially it's silicol FC, T3, you can see. And aerobic stability, temperature dynamic of exposing to higher period. You can see graphs, what happened, and this Bushneri and Lactococcus lactis was very effective in improving, is prolonged, was being aerobic stability, and started deteriorate silages last of from all silages. And you can see this aerobic stability hours and in both stages of maturity. And deterioration characteristic, weight loss, you can see during aerobic stability test. pH is showing very clearly effect of additives and yeasts and molds counts or number in silages at the end of aerobic stability test. And we are thinking that is very important items to explain these additives effectiveness. And conclusions. Improved all inoculants fermentation, homofermentative improved fermentation profile and reduced dry matter losses in both stages of maturity, but impaired aerobic stability. The product containing homo and heterofermentative lab improved fermentation profile, reduced dry matter losses at all stages of maturity, but aerobic stability was improved only in early cut rye silages. This strain combination can be recommended if rye is harvested at early cut growth stage in the double cropping systems. And last one, the dual purpose inoculating containing Bushneri and lactic supported good fermentation with reduced dry matter losses and ensured long-lasting protection against aerobic deterioration by instant molds independently from the actual maturity change of the crop. And I think who is working with these inoculants, it's maybe true because we know that Homotrativa lab is reducing dry matter loss, do this specific fermentation profile and this heterolactic lactic acid bacteria is, of course, reducing aerobic deterioration. Thank you.
Thank you for your presentation.
I'm sorry, but I will present another one, okay?
Yeah, okay, it's fine.
We agree to do that.
Have somebody some question?
Maybe questions after both presentations.
Yeah, please.
Jonas, I have two questions. First of all, I'm quite surprised about this very low crude protein level in the early cut dry. I mean, in East Germany, we would be looking at 15, 16%, and you roughly had 10%.
No, but we get these results from chemical laboratory, and we can change. You think that in the raw material?
Yeah.
Oh, in this one, yeah.
So do you know anything about the N fertilization rate? No.
I can explain.
Okay.
Why? Because we get results, and we can change them, sorry.
Okay. And the second question is, you have found significant differences between treatment 2 and 3, given that the inoculation rate was identical, 150,000 CFU per gram, and the proportion of the Buchneri in the same, it was the same, 50% in both inoculants. Could you explain why you have such significant differences in aerobic stability?
You mean
treatment 2 and 3 have 50.
We have some differences, but you mean that the same percentage of Buchneri?
Basically, you have applied the same number of Buchneri per gram fresh matter, but you find pretty huge differences in aerobic stability.
But I think that this Lactococcus lactis maybe did something, change in fermentation profile. But now I can't explain for you. I need to look. I'm sorry.
Have you still some question? Yeah.
Thank you. Thank you for presentation. And I have one question. Inoculants influence the occurrence of fungi, of molds, but can influence content of mycotoxins?
Of course, because if less number of molds, it's less quantity of mycotoxins. It's very important regarding hygienic quality of, especially for dairy cows, is mycotoxins very dangerous, aflatoxins, and we don't test them because they're expensive. But it's your suggestion very good to test mycotoxins. Will be very good. But we suppose, we can't speculate that it's must decrease mycotoxins.
Okay, thank you. And now you will continue, and it will be the last presentation of this day.
I will try. Wow. I'm sorry. Thank you. Can you size? Oh, thank you. This was being done field trials. There's two raw material, is maize or corn and whole crop barley. And we investigated in these two raw material these two inoculants. Sorry, one inoculant and one control was been. And big bale silages, they are produced either from Koláčková barley at dog stage of grain maturity and plant maize, dog stage of grain maturity too, and was being ensealed in big bales. And this using, of course, different equipment. Now it's very good that we can do big bales from chopped maize. It's by using this machinery. Analysis was being done the same like before. Fresh forages was analyzed, silages was analyzed, 120 of storage or fermentation, aerobic stability in the field and in the laboratory, and results at the end of aerobic stability test in the outdoor and in the laboratory. What differences this aerobic stability testing in laboratory in the field? Because for laboratory aerobic stability testing, we taking 1 or 1.5 kilo of silage and put plastic capacities. But in outdoor, we are using discovering these big bales, and that I can release freely to bales. Results. You can see characteristic of forage before ensiling is barley and corn or maize. We have tested some nutrient composition and yeasts, molds, and lactic acid bacteria, epiphytic lactic acid bacteria. And now fermentation characteristic. You can see that was done big influence this additive to dry matter corrected for volatiles concentration, and especially dry matter losses was reduced statistically, was been significantly, and ammonia N was been reduced too, and increased lactic acid concentration and acetic together acid concentration, but in good proportion, and was being decreased butyric acid concentration too. Now propionic acid concentration was being slightly increased and alcohols decreased. And pH, of course, it's differences we can see because inoculant is stimulated fermentation. And you can look microbial, very important now, I think, to describe about hygienic quality of silages is yeast and molds number in silages. It's very effective was results in both in barley and in maize too. And aerobic stability test. You can see graph in outdoor because it's this very depend from outside temperature because temperature is at night and at day increasing and is then average results. And you can see that did some impact this inoculant on aerobic stability. It was been improved. And temperature dynamic in laboratory, it's results same like in field testing aerobic stability. You can see that was bit prolonged aerobic stability when we used this inoculant. And last one, aerobic deterioration characteristics, and was being decreased at the end of aerobic stability test yeast count, like in the field and in laboratory test too, and molds, of course, the same results we got. And as you asked again, it's indicator that we can wait that it's, of course, you're right, yeast and molds is not dangerous, but dangerous is the products what they producing, these molds. And yeast mostly producing head in way fermented. Characteristics, it's the same with Koláčková barley and Koláčková maize. And we tested his fresh weight loss outdoor and fresh weight loss in laboratory because it was being weighed before aerobic stability test, his bales, and after aerobic stability test. But in laboratory, of course, is better to do this is not difficult. It results similar in field and in laboratory. In conclusion, we can say that adding this psilocybin as containing lactic acid bacteria, Buchneri and plantarum and fascium to hula plant barley or hula plant corn and sealed in big bales, improved fermentation characteristics, reduced fresh matter and dry matter loss, and suppressed growth of mold, yeast, and Clostridia, and ensured long-lasting protection against aerobic deterioration. Thank you.
Thank you for your next presentation. And have you some questions? Everybody is tired, so.
All is tired.
Yeah. So.
Okay. Yes, it is the best time to do presentation after lunch, of course. Thank you.
So thank you very much.
Thank you very much.
And now we can continue at the posters and we can individually discuss there about our results. Thank you. So good morning. I would like start second part of presentations from section 1, and first presentation is Professor Roof, and he will tell us something about intake of forage and healthy and performing of cows. So, you can.
Okay, so yeah, thank you, good morning, or lunchtime, whatever. Thank you for the invitation. It's the first time I'm here at this conference, so I do like it. And yes, my topic was introduced, so I'm from Northern Germany, and well, let's say this is probably not the most scientific presentation you will enjoy, but I think it's still important. Also, I think there's a little bit of entertainment in here. So, but it fits pretty well, I believe, to some of the topics we have already heard. And I will start with this one. So this is more on the management stuff and on cow eating behavior. I think it connects pretty well to the presentation as of yesterday with the fiber digestibility, but also on well, the aerobic stability topic we also touched this morning. So I would like to start with this sentence, which is also in the article I put together, and I think nobody's going to challenge that ruminal pH is an important topic. That if you have fluctuations there, and if you have fluctuations in ruminal pH, usually you also have fluctuations in feed intake, and well, a number of topics I would like to mention here, what to look for from a practical farm perspective. But also, I mean, it also comes down to silage production to a large degree. I just usually use this slide. I think it was put together in Gumpenstein several years ago using a BOLI, and you can see the ruminal pH over a couple of days. And basically, as far as I know, both of those colors represent the same diet. Same diet, same silages, only the management of the feeding was different. And I believe we are all looking into what products are doing, and products are performing well, but we also know that management is a large topic. So this one is on management. And during a lot of work on farms over a couple of years, you see at some point what brings you on the green line and what management topics more help you to stay on the purple line. Obviously, the purple cow will behave a lot better than the green cow. And I would like to give you some examples. This is a very easy example, and all of the pictures here I did for that company when I was working for them. I took myself, so I can also elaborate a little bit on what was happening here. This was a good farm, 350 cows, close to 40 kg with two times milking, so they knew what to do. And still you can, and this is one large group, and you can still see, well, they changed the silages. And if you are starting with silages, then you will have fluctuations in dry matter content. Certainly also the fermentation plays a role here. And at some point there will be rain, and then you're messing it up basically. And this is what happened here. The interesting story here is it is the same group, both cows, so they can switch sides here. And the point I want to make is if you just have a look onto this spot, how many cows are switching from this side where for several hours there's no feed to that one over 30 minutes. While I did count them, it was 13 cows and 8 only went over there to pick up feed. And then per chance, we also washed the feces, and what we figured out that the passage rate is too high. Yeah, well, guess why? And then the point I want to make here is, this is obvious. If these cows are not eating anything, the pH will go up for a couple of hours, and at some point they will eat something, and the pH goes down. Another topic is this one. I think we also are all aware of this, that it is going to happen. And you can do a lot when you do advice at farmer level using cameras in a way. So obviously that one is sorting, and sorting also results in pH fluctuations. And sorting can have a lot of reasons. It also goes a little bit back to silage production, where I'm heading to. This is also an interesting one that's actually from Denmark, milking 3 times. So I took videos when the cows are coming back from milking in the morning at 5:15, in the afternoon at 1 o'clock p.m. and in the evening at 9 o'clock. And if you like, you can try to figure out at what time point they have been fed, those cows have been fed, because you can see when the cows were fed. We just have a look into how many cows are laying down when they're coming back from feeding. So obviously, when cows are laying down, the feed is probably not too attractive or less attractive. And if you just have a look, less cows are laying down here, more here, and most here. So obviously they have been feeding at the morning at 7 o'clock or something. So the remainder of the feed is not very palatable. A lot of reasons are here, but certainly heating is one point, sorting as well. Huh? So I think it also, when you do this kind of stuff, it comes down a little bit to the question, do you have something? Do you have fluctuations, whether it's pH or passage rate? And if there's an issue, is there a short-time fix? I mean, you need to do something about it right now. But the long-time, I always think, well, that's silage production. So what can we do when we are doing advice on farm? In the end, we want to sell products that are helping the farmer. But what other advice can we give to a farmer to become better here? Just one more example on the palatability of oats. This is the same farm. They have been feeding in the morning. And so I took a video at 2 p.m. in the afternoon and at 4 a.m. in the morning. And again, just have a look into how many cows are eating. I mean, if you're having a 3-row barn, then obviously 1.5 cows are sharing one feeding place on average. But if you see something like this, then cows are not eating 24 hours or 24/7. So it's not 1.5 to 1, but it's more like 2 to 1. And the more cows are sharing one feeding place, the more fluctuations you will have in feed intake, etc. So in this farm, actually it was heating, but not related to the silage at that moment, but more because they didn't push out the feed every day, which is, well, you find that. Even at 30 kg, which is not bad, I believe. And they had a tremendous amount of sorting. And both of that led to this situation. And well, if you don't have a management system, activity measuring system, or do something like this, you won't figure out that the cows have not been eating at night because there was feed enough. They could have been eating something, but it didn't. One issue which frequently happens and is still not related, this is still the short-time fix in a way, is if you just have a look into where and the process of the mixing. I just took those pictures. This was RMH mixer, and this was a BBL. But in the end, the brands do not change so much. What is interesting, though, is if you don't know the process so well, it does mix, and there is movement. But usually mixing means that something is being pushed up in the middle, and if something is being pushed up in the middle, then something is going to go down at the outer side. And as you can see, nothing is happening here. So that might be one thing, that the mixing is not perfect. And that, well, sometimes it's more difficult to fix, but usually you figure it out. And I've had instances where you fix something like that and you get 1 kg or something more milk. An easy thing to do, and this is not rocket science, but it's still important, and we are always looking a lot into scientific stuff. But in the end, I also believe that we still have to keep doing the basic stuff. And this is just being used of the Penn State sieve. And you can see I did those 10 samples over the feed bank. So, I mean, if the feed bank is 100 meter long, then I took a sample every 10 meters to just reflect what is going out of the feed mixer and to see whether it's always the same. And what you can see is, just look onto the top line, which is the longest particle size. You can see that there are virtually 3 or 4 diets here, and even if you think that you're feeding the same stuff, you're not. And then you also find the sorting. So the average of those 10 samples is this one, and then I took 1 sample of the oats, and you can see the sorting of the cows. So on the average on the upper sieve was 23% in the fresh TMR, and in the remainders it was 46%. And the fine particles were gone, or at least less. So this is a clear thing that we do have sorting present here, and the reason is that the mixing was really not perfect. And okay, you can change the mixing order, you can change the mixing after last component or something, you can help with that. Sometimes you find this. If you just look here, you still have sorting. On the top sieve, on average of those, well, this looks pretty well, doesn't it? It's not perfect, but it's actually quite nice. So you have some fluctuations still, 21 and 30 or something. On the top sieve, 33 sometimes. So it's still a different diet, but it's certainly better than the other one. So if you just have that, would you change something? Not necessarily. But if you then look into the sorting, you still see on the top sieve of the fresh TMR, the average was 27, and the remainder was 60. So there was a tremendous amount of sorting. And while that was a farmer, we were talking this morning on acetic acid and whether it's helping against the effects on feed intake, etc. So this farmer was having a lot of issues, or some issues with heating in his silages, and he didn't want to add water to the diet because then you have even more heating. So at summertime, yeah, he found the issue, it gets warm, because he took the wrong solution, taking out the water, because then you have sorting. Right solution would have been add something as a preservation to the TMR. So dry matter content might be an issue. But grass silage can also be, or silages per se, can also be a large thing. This was a 600 cow dairy also at 35 kg with 3 times milking. You can see this video was taken at night, and well, this is sorting. We also always look into the eating of tunnels or something, but grazing of bunk is also a tremendous amount of sorting. And also, there are easily 100 cows in this group, and we see 2 cows eating. So obviously, they are feeding in the morning. Obviously, the feed, the odds are not very palatable, and they are sorting like hell. And the reason here was that the grass silage was really bad and acid, and it was hitting at the top. So for a long time, the cows can eat a lot of stuff which they like, and at some point, the diet changes over time, as we are all aware of, and at some point, you only have this stuff there which nobody wants to eat. And honestly, I mean, in the last presentation, we saw also one important tool for me is obviously the thermometer, but also the infrared picture. But I took this infrared picture of this clamp, and in the first view, you would believe that it is fine. And then I was also surprised to put the thermometer in there, and you find 50 degrees C. So I think it's always a combination of things. But one thing is for sure, and this was a farm in northern Germany. This was the close-up group, and I believe that we are all aware if you have 30 degrees C in a close-up group feed, what is going to happen. They are eating less before calving, and you have more troubles after calving. And then, I mean, I do buy what was said this morning, that there are probably better measures than acetic acid to get away with heating, and management is a large thing. But honestly speaking, if you do something like that, and cows are not eating it, and reflect all the pictures and videos I showed you, I mean, that is worse. From my point of view, we have really to ensure that it's really palatable feed, and that cows, that you're not only trying to prevent heating, that cows, now you can cut it short and things like that, and do a good job in mixing, and even the worst food you can try to hide somewhere in the TMR. But if you really want to go high in milk yield, then my experience is you have to have a feed which the cows really like. And then heating is absolutely not what you want to have, what you want to have. And acetic acid is one point that is helping, and there are some inoculants who do that. So that is, for me, that's a showstopper. Another point, and then we're coming more to silage production, in a way, is have a look into the chopping length. I mean, just took this picture, it's also a good farm, those beet pipes, I don't like them because it will mean sorting, but okay, they are there. Then the red thing here is what you find here, if the corn silage is chopped too long. If we're talking on shreddage, I'm all in for shreddage in certain diets with a lot of corn silage, and I think the research may also reflect that. But there's also one pitfall. If dry matter content in the stover goes up, then at some point you will have those long particles and they accumulate in the orts, and you find them in the TMR. And the other thing is with those balls of grass silage. One thing is that cows can sort for it or against it, that's one point. And the other point is it's a little bit like potatoes or those beet pipes. there's water hidden in here, and it's like in a cage. It will not get free, so there's a risk that you have more sorting, because maybe you go for 38, 36% of dry matter in the TMR on paper, but the reality is different if some amount of water is still in these balls. So I think cutting length and dry matter content are important things to consider when you put together all silages, but grass silage in special. I found this one, which Grant showed in a webinar in 2020. I think that was a 3-state conference. And what they did, and I don't want to go into the weeds here, but they had a grass silage, corn silage diet. I think it was 60-40, 40% of grass silage in the forage and 60% of corn silage. And they cut it early or late, high and low UNDF contents or high or low fiber contents. And within this, they chopped it short or long. And just as an impression, here you can see the dry matter intake. Well, we all know if we are cutting grass silage too late, then dry matter intake goes down. The interesting thing, though, I found is that if you have a high fiber and if you have a late cut, but you are then cutting short, that is really helping with milk yield. Or in general, it's helping with milk yield. So from my perspective, I have experience with good farms, though, if you go down to 1 centimeter or something with grass silage. And inoculant, well, I would always put them, but because of palatability, but there's also something like quality. If you're looking a little bit into the production of corn silage, I think fiber digestibility was covered yesterday pretty intensively. I really regret that we are not able to be there, so I just read the proceedings. But this is a trial here which I find interesting, and I believe that we see that more frequently. So this is on the impact of water on the fiber digestibility of corn, of the sova, so basically. And it's just a try, but I found it nice, and it is what it is, and there's more. But this is just a trial where they had really dry conditions, or they irrigated on different locations. And what you always see is if you have less water, then you have better fiber digestibility in corn. But you have also less starch. That's the downside, and I think at least in Western Europe last year was pretty dry around flowering. And then, well, I just talked yesterday to a farm manager who said, well, I have little starch in there, but they are eating like hell. So fiber digestibility, I think I'm not covering the management, what we can do here, because it was in there yesterday, chopping, height and things, brown midrib are other topics that you can do. I would also like to look a little bit on flint versus stand. It's a topic that we've been covering for quite some time, and which I still believe is worth mentioning, so this is why I'm putting it here. This was a trial which was done some years ago, where we had a pure flint variety and a dent variety ensiled for 2 months or for 6 months, and we had a look into the starch in the feces, and you see there is an impact of flint and dent. It also comes down a little bit of the dry matter in the kernel, so you will find less difference between the two of them if you are low in dry matter, but then you are sacrificing yield. So probably you get higher in dry matter, 35 or something, when you're harvesting, and then you will find this. And I mean, if you get out 4.5% starch in the feces, that means that also there's not, well, the amount of starch that is really in the rumen is lower than at that moment. And this is, again, the same topic. Before I come to my conclusions, it's again flint and dent. I'm not sure whether sometimes it's good. If you have those flinty hybrids, well, let's start with the dent. You have the floury starch with white. And the vitreous starch is this yellow stuff here, and vitreous starch usually is less palatable in the beginning at least, because it's embedded in a protein matrix, and with floury starch it is less the case. We did I thought, a nice trial. It's just a practical trial in the field. We had, I think, 2 hybrids mentioning here, several rotations, and we were just picking ears, and at that time we sent them into the US for 7-hour starch digestibility. So what you see here is the dry matter content of the whole plant, and here's the 7-hour starch digestibility. And well, this was done in Germany, so it's quite a dainty hybrid for German measures. Italian will probably see it's a little bit different for them because they have different maturities, and also in the US, if you are going higher maturity, usually it gets more dainty. So what you can see is that with a dent, you see some decline in starch digestibility, but in the mixed type, and this is not the pure dent, which is hardly being sold anymore, but in the mixed type, you can see if you are harvesting at a later time point because you want to catch up the starch, then your starch digestibility goes down. So it's also something that you probably want to keep in mind, and kind of processing is a topic here, and also the ensiling duration. I think we are aware, but maybe something which is still worth to mention because it's also something you can manage. So if I may put this together, then I do believe, and as I said, I hope it was a little bit entertaining. I wanted to show you some tools which you can use. It's really very important that cows are always eating 24/7, always the same feed, so no sorting everywhere. So put really everywhere the feed, which is really important. And there need to be sufficient amount. I usually think that 3 to 5% for the high strings are and palatabilities, and then this relates to silage production. There's a number of stuff you can look into. I think I showed you some, and silage preparation for me is key because it's just always the future to get more feed intake. Thank you.
Thank you for your presentation. Have somebody question? Yeah.
Did you show some that data regarding the particle size distribution? Yeah. Have you recommended some guidelines for retention of the offered diet to avoid, for instance, sorting or?
Yeah, yes. I think the recommendation that is out, and which I do like, is that on the top sieve you should be below 5% or at minimum below 10%. But then if you have diets with a lot of grass silage in there and with a loading wagon, it will be hard to really obtain it. And then my personal opinion is that if you're doing something like this, I mean the average here on the top sieve is 27%, cows will be able to sort. On the flip side, then it's so important that you have a grass silage which cows like. And then we're talking on silage production and heating and things like that. But my recommendation, if you ask me what is nice, then I would say 5% is a good.
Yeah, I agree. But even in case of forage where the cows like, it will also give problem because one cow will eat this.
I agree.
And the other.
Yeah.
It's the problem for both palatable or unpalatable feeds.
I'm 150% of your opinion. Yes. And the same is true, by the way. I mean, I'm having a four-fold sieve. I put together the last two ones here. So if you go into the bottom sieve with a narrow sieve over. The other thing is you also need as little as possible in the bottom, maybe like 5% or something.
Thank you. Have you still some question?
What do you think is the best dry matter content for TMR mixtures that you have no sorting effects?
I do believe that the compact TMR is a nice thing, let's say like that. And then you're really going down, but not every farmer likes to do that. So I found if you're doing a good job here and dissolving grass silage and really mixing well, then 38% is a nice starting point. This is my impression. 36 sometimes. But if you go beyond 40, then you will have sorting, I think. But on the flip side, there's also people arguing then that the passage rate may go up. Yeah, it's also something that you have to consider.
So I would like ask you, you spoke there about the effect of physical effective fiber of grass silages. So can you tell me what was their theoretical length of cut or?
I was fearing that you're asking it, and I did not look it up, but I do believe that this was 1 and 4 centimeters, but it's a little bit of guessing now. That was quite a difference in this trial, right?
Yeah.
It was quite a difference.
And have you some practice, what is the best theoretical length?
Yeah, well, I think for good farms, I would argue do 1 centimeter, sometimes 0.8 centimeters.
For grass silages?
Yes. I would argue to do that, but you really have to ensure that you are on the purple line, because imagine you are having somebody is not feeding his cow or pushing up at night or something. Let's say cows are eating not for 3 hours because milking time is too long, because you're not pushing up, because of sorting or things like that, and then you're bringing the fresh GMR with all short material. Then you will have a high passage rate, and you will find canola or corn grain in the lower intestine, and that will create troubles as well. So I think you have to figure out a little bit. If you're simple,
it depends on a system of
yes.
ensiling, because when there are balls, so it is impossible to have 2 centimeters.
Yeah. If you're on the purple line, if you're doing a good job in management, then cut it short. My personal thing.
Okay, thank you. So is still some question? No, so thank you for your presentation. And next presentation is about harvesting technique of alfalfa. So please start.
Thank you for the introduction. And dear ladies and gentlemen, I will present you some of the results of a bigger study which has been done by our institute. It's about the harvesting techniques, and we are aiming to produce high protein feed from alfalfa, but mainly for the monogastric animals. And of course on this work I wasn't working alone, but with my colleagues from the same institute, which is situated in the south of Bavaria, and also with the colleagues from the Technical University in Dresden and relatively small company which is specialized for mechanization. It's called Brandlandtechnik. And actually, why did we, trying the second one. Okay. So why we are focusing on actually to produce the high protein feed from alfalfa for monogastric animals? It has something to do with the current situation and the changing situation in EU organic farming, the legislative. So there's a new regulation in force coming, and it says that there is need to supply such farms with 100% of the organic feed. There are some exceptions, for example, for pigs with a live weight up to 30 kilograms and so on. But overall, it has a big impact on the farms, on the organic farms with monogastric animals. And one of the solutions which can help is actually to use the forage legumes, and especially to use their higher amino acid and protein content. But this one is just actually, you will find it in such a concentration in the leaves and in the plant tops. And that's why we actually wanted to develop a new techniques how we can actually separate the leaves from the stems of alfalfa, or how we can cut the plant tops. So within this study, we focused firstly on evaluation of the first machine prototype. I will come to that later. And this was separating, it's on the picture on the left side, and separating the leaves and stems directly on the field. And secondly, we came to an alternative technique, which is not separating leaves and stems, but cutting plant tops with very high amino acid and protein contents. Yesterday we've heard that we should not make like 2 steps on the field, like firstly cutting upper part and the bottom part of the plant. It was by corn. By the alfalfa, it's a bit different. We have already in Germany, it's in the south and in the east, some of the farmers which are using this similar technique, and it's profitable for them. Coming to materials and methods, so these are the two techniques which we compared, the machine prototype and the second technique, which was actually harvesting the alfalfa plant tops. I'm not the best painter, so as my colleagues told, it's not a tree, it's the alfalfa, and just I wanted to show you that this was approximately the 70% of the height which we harvested. And in the second step, the rest of the plant has been harvested. There are also some other possibilities. We let in some of our experiments to regrow the plants, so we didn't harvest the rest of the plant. And it also works, but it's really depending on the weather conditions after the high cut, so-called. We had both machines at the same field and the same year only for the first cut of 2020 and 21. Unfortunately, these first cuts of 20 and 21, they were completely different from the weather conditions. So in 20 we had very dry weather with very low precipitation, and in 21 it was vice versa, opposite way. We had per technique 4 to 6 large plots with a bit different size, because the size was adjusted to the brightness of the harvesting technique. And we calculated dry matter yields per cut and hectare, estimated then in the laboratory the crude protein and amino acid contents, and also we developed at the institute using NIR's new method how we can estimate a leaves proportion in the harvested material in %. Data were then analyzed, statistically analyzed, but due to the costs we analyzed, or we had enough, of course, information about the dry matter year and leaf proportion, but for crude protein and amino acid contents, we always provided a mixture sample of these 4 to 6 large plots, replicates within the technique and the cut. That's the first technique, and how this worked. It's actually quite usual harvester, combine harvester, but our colleagues, they optimize, or there had to be done some optimization. So first of all, and the most important part was the emptying of the grain tank. And in the grain tank, actually, we had our separated leaves. Further on, pickup had to be also optimized, and we tested different sizes of sieves. And how the procedure completely worked, so we firstly cutted the whole plant of alfalfa, wilted on the field up to approximately dry matter of 65%. And then in the next step, the harvester was then separating the leaves and stems and left the stems on the field. What's important there is direct storability of the harvested leaves in the corn tank. If we have very optimal conditions, weather conditions during the harvest. And this I wanted to show you in the table. On the left side, you see the dry matter of the swath before the harvester is coming. And completely on the right side, you see then the dry matter of the separated leaves in the grain tank. So we can see that they are already, they have a dry matter of around 88%. We tried also some extremes and very wet swath with about dry matter of 33%, which then of course is resulting with the leaves harvested in the grain tank for about 47%. And also you see in the middle of the table the leaves proportions in % in the material. It was almost 50-50 on the whole plant, on the swath. Around ranging between 79 to 86% of the leaves were then in the grain tank, separated leaves. But in the stems, under good conditions, there were no leaves. Under bad conditions, still almost half of the leaves were left or mixed with the stems. We were also then interested in the leaf losses on the field during the drying period, so before this combine harvester was coming. And for that we used the NIRS technology, and you can see, for example, that in this case the initial stand of alfalfa had 57% of the leaves. By tedding and windrowing we are already losing some of the leaves, and by windrowing 12% of the leaves were already left. We couldn't harvest them, of course, they were left on the field. Well, because this technique is still kind of in the prototype stage, it works on one farm in the south of Germany. We were searching some other possibilities, and we came to this machine, and it's actually called Top Cut Collect from Copani Giuseppe. And we see it as an alternative to leaf stem separation. So some of the farmers, they actually came with it to us, if this is possible. It's relatively simple, double blade cutting system. It has a special reel and collecting hopper. But there are again some adjustments necessary before the practical use. And one of the adjustments is the collecting hopper, which is very, very small for our purposes, because the purpose of the machine was different before. The cutting height is adjustable up to, of course, 140 centimeter, 3 different working widths. In our case, we used 9 meter. And in the experiments, we firstly cutted the plant tops at this height of around 70% of the plant. And the cutted plant tops were immediately hot air dried. It would be also important, or actually had some positives, if we could have wilt them before. We could save much more energy and money for the heat for the drying process. And in the end, these plant tops were processed into cobs. And the plant rests, just in our experiments, they had been wilted to approximately 60% of dry matter, and then again dried and harvested. And here is another example of leaves losses. Initial stand again had, in our case, 52% of the leaves. Then we did this high cut, and we had the plant rests. The plant rest still had around 40% of the leaves. And by tedding windrowing, we again lost approximately 9% of the leaves, so before the harvest. Now coming to the dry matter yields, and then later to crude protein contents. And as I said, both years were extreme. So the first cut, 2020, the plants were very low, bad developed, and it also corresponds to the dry matter yields. So this is the first techniques. We divided the yields to leaves and the stems, and second techniques and the plant tops and plant rests. And we see that in the first year we had around 1.2 tons dry matter of leaves, which we could harvest per hectare. In the second year, around 2 tons. Plant tops, in this case, just 450 by very bad conditions by the harvest, 730 in the next year. This is just typical for this field. We did this experiment where we could combine both techniques at the same time. We also tested the techniques on different fields, and we came up, for example, with the plant tops under very good conditions to yields for about 1.3 tons per hectare. Plant rests are still valuable and differed of course during the years, and differed of course in between the techniques. But what is interesting for us are the crude protein contents highlighted in green, and especially by the leaves and by the plant tops. And by the leaves, so using the first machine, we could gain about, get a crude protein content about 260 gram per kilogram. By plant tops up to 318 grams per kilogram. Under even better conditions on a different field, we could get by plant tops with crude proteins to about 340 grams per kilogram. This is not a mistake. What you see here is identical values. We can explain it a bit because the first cut in 21, during this process where the plant was actually left on the field and dried, we got some thunderstorms with actually, and the plants got relatively wet. So the machine didn't work pretty well, and we had still many leaves left. And that's why also the crude protein contents were quite high. Relatively high. And here you see some of the example for the lysine, methionine, cysteine, threonine, which is important for the monogastric animals. We couldn't calculate any statistical analysis based on the single values, but overall we see that the plant tops looks like they have a higher values of such amino acids compared to the leaves harvested with such a technique. So coming briefly to conclusions, I showed you two of examples which we tested. They both have some advantages, disadvantages. By the first techniques, by the harvester, big advantage is the higher dry matter yields, relatively good crude protein content. And disadvantage is still in the prototype stage. Our colleagues, they already used the leaves which were harvested by this machine in the pig feeding and could use up to 20% of the concentrates in the mixtures. The second technique, we have to use a specific machine. We have very low field performance. We have also low dry matter yields. But on the other side, high crude protein contents and amino acid contents. And that's why in this year we are then focusing to test another mower instead of the second technique. And it's kind of front butterfly where we expect much higher field performance. And what we will also investigate is the drying process in the hot drying feed producing company and degradation of the crude proteins there. So that was briefly from everything from my side. Thank you for your attention.
Thank you for your presentation. So now it's time for questions. If somebody, I would like ask you, maybe you told it, but you had there that you use near technology for measuring of proportion of leaves, where you took equations or.
So we had many samples. This project was running for many years. So we had many samples from different fields, and this calculation I haven't done, but one of the colleagues, and we were like separating at different heights the leaves and the stems. So and this was taken into
you
the
use
equation.
yours equations, yeah. Okay, and you plan some selling of these equations or something like this?
It's actually I don't think so, because we would need, I mean, in case that it should really work really precise, we would need every year new samples to get into the, and this is really time consuming and also cost consuming.
It's true.
So we will not, I don't think so we will sell it.
Sometimes I think it can be interesting for nears on machines, not only for these technologies, but for measuring when it is cutting or something like this. Yeah. So it can be future.
Okay.
So thank you.
Thank you.
There is a question.
I've got a couple of questions. First of all, what kind of, or what categories of pigs do you want to feed the leaves to? Is it just across the board? I mean, lactating sows, pregnant sows, piglets, or fattening pigs?
Actually, the experiments have been done on lactating sows and on fattening pigs.
Okay.
We have to, actually, originally, and we also, the other colleagues, the other institute, they provide some experiments also on poultry. But we have a big problem by the alfalfa with the contents of saponins.
Okay. And the next question is, if I understood the concept correctly, then you would harvest the leaves or the tops, and then you would dry afterwards, right?
Yes.
Okay.
Or wilt it. This is the next step, firstly to wilt it them and then dry, hot dry.
Okay. What temperature, at what temperature do you dry?
The temperature is actually there are in the south of Bavaria these hot air drying cooperatives of the farmers. It starts by 200 degrees and goes up to 600 degrees.
Okay, and for how long?
It's at least what they told us, couple of seconds. This high temperature. There is a low temperature before and after the process.
It would be extremely nice to not only look at the protein concentration, but also on the protein quality, meaning undigestible
degradation,
protein.
Yeah, that's what we have this year. That's I said in the perspectives.
And by the way, I mean, lactating sows could also be fed whole crop alfalfa silage.
Okay.
So still some question? Yeah.
I have one question which is dealing about the rest of plants. Can you please say me, you measure NDF on if?
No. We have just these values which I showed you for the rest of the plants. So we had just the crude protein, and we didn't also estimate the amino acid contents by the rest of the plants because of the cost issues.
Okay. Yeah. Thank you.
Okay, so thank you for your presentation. Okay. And next presentation will be about new microorganisms for ensiling of different forages. Please.
Thank you very much. To start quickly, silage is of course important. For high productive cows, healthy cows, we were talking a lot about that. If it would not be true, we would all not be here, of course. Unfortunately, while silage making, farmers will face losses. It's normal. There are some losses regarding environmental factors like rain. There are some losses regarding management. You always will have losses, totally normal. But if management is maybe suboptimal, losses might be high. If you go on real farms, the situation is even maybe a little bit more tricky. It means farms have a lot of challenges. Labor, most farms don't have enough. Investments in machinery, technique, like chopping machines, like tractors for compaction, good plastic, good bunker sizes, good bunker conditions, the walls and so on. I brought here a small example by compaction. If compaction is not so good, let's say, silage will be warmer. If compaction is better, silage temperature and aerobic stability might be higher. If silage is facing some aerobic stability issues, what does it mean? Cows will consume less silage. So that is an actual problem on a lot of farms. Besides good management, we all know heterofermentative can help here. It means heterofermentative produce acetate, propionate, that substances will reduce mold and yeast. If number of mold and yeast is lower, aerobic stability is higher, and losses in the end are lower. Unfortunately, there is already a new challenge upcoming, climate change. Here in Central Europe, the last 3 to 4 years, we had a lot of surf droughts. At the moment, like South Europe, Bulgaria, Italy, they face surf winter drought. There's no rain, no snow. So there will be problems, even more problems in the future. It means farmers will have maybe not lower yields, but at least more variable yields. Some years are good, some years are maybe not so good. So prediction of yield will be very difficult for farmers. And also the silage itself might change. Could be more wetter, but also could be more drier with higher sugar contents, higher harvesting temperatures, all leading to increased risk of aerobic instability. And already in the literature there is written we need inoculants that increase the aerobic stability already in a short amount of time. It means that farmers are more flexible to open their silages earlier if they need, because they have not enough forages to feed their cows. Buchnerie is a very nice solution, and it will stay a very nice solution, but unfortunately it's not fast enough. It takes at least 60 days to increase aerobic stability, so in the end we will need a new solution. One of the solutions is the new Lentilactobacillus hilgardii. So here you see a test for short and mid-term fermentation compared to a control, compared to pure Buchnerei, and compared to pure Hilgardii. What you can see, we're producing acetic acid faster in a very short term, but also in mid-term. The same for propanediol, and in the end, that leading to lower yeast count compared to especially control after already a very, very short amount of time. And that leads to the higher aerobic stabilities the farmer need. So if you compare the 74 hours, for example, to 51, 50, 52, 53, we see already after 15 days a higher aerobic stability. What about long term? Long term is, of course, as important as short and mid-term. We also see when we use a combination of Buchnerie and Hilgardii, we see, especially compared again to Buchnerie and Hilgardii alone and to control, we see a higher aerobic stability on long term, 250 days. We see also the influence on the peak temperature, we have a lower peak temperature, and so on. So all aerobic stability parameters are better with a combination of Hilgardii and Buchnerie. You can also ask, why is it just acetic acid? It is of course not. We were starting a little bit to talk silage microbiology and about, like, maybe call it a little bit the clean silage. When we use the combination, we will reduce the total yeast count already after a short amount of days. And even on the long term, we will reduce the yeast counts even more compared to a control. And quite interesting also, when you check the dry matter recovery, especially here on high moisture corns or a high value feed, dry matter recovery compared to a control, similar. We have not really more losses. Again, why do we see it? We have an early domination of the added microbes. You can see here, lactobacillus, we have them already after 10 days, high domination, especially compared to control, also after a longer term, and we reduce the unwanted silage microbes, like, for example, Enterococcaceae, Clostridiae. We reduce them compared to a control. And, of course, also very important, we reduce the enterobacteria. This was during ensiling, but we were also talking about the feed out. The feed out is even maybe more important because that is what the cows will eat. So here you see a metagenomics analysis about 10 days of aerobic exposure of a maize silage. On the top, bacteria diversity, on the bottom, fungi diversity. What do we see? A treated silage, the added bacteria, they will dominate the silage even during aerobic exposure. On the other hand, in the control, we will have, especially like in the last days, domination of Acetobacter in that case. For the fungi, we have a shift from control to treatment to non-lactate assimilating yeast. It means we have lactate assimilating microorganisms in the control and non-lactate assimilating yeasts and microorganisms in the treatment. And what we also see here, it's not just number of yeasts in the silage, it's also the nature of the yeast. What are they doing in the silage? If we see a warm silage, we in most cases also see mold. If we see mold, the risk of mycotoxins is high in the end. Again, if we use the combination of Buchnerii and Helgardii, we have a reduced risk of new fermentation of mycotoxins during aerobic exposure. We see it here for ROC14, we see it for fumonizine, we see it for DON. Other ones, they are not always responding, some come from the field. So in the end, to sum up, combination of Helgardii and Buchnerii increases aerobic stability of corn silage and high moisture corn after already short, but also mid and long-term fermentation. And it's better than Buchnerii alone. Buchnerii alone, still not bad, but combination even better. And very important, we see also the shift, the change in the silage microbiome. With that, also we reduce the risk of mycotoxin production in the silage. So in the end, that combination is one of the steps, besides the good management and so on, to adapt silages for future challenges. Thank you very much.
think it is better to advise farmers in properly planning their feed inventory, not to be forced to open silages after 30 or even 40 days?
Maybe start with your first question, with the second. Absolutely right. It's not a recommendation for farmers to open early. It's just if it's needed. So the longer, of course, the maize silage is closed, the better. And if a farmer can manage to open the silo after like longer time of fermentation to get the highest starch digestibility, absolutely yes. But unfortunately, in practical agriculture, is it not always possible, especially when you have really like a drought, low amount of feeds, maybe in several years in a row, it can be tricky. And then it's always like thinking about what is the farm needing, feed, starch digestibility, both is very important, so it's always to find a balance, yes. First question, Hilgadi alone is working especially for the short-term fermentation and aerobic stability. So yes, there is a synergistic effect if you combine both.
Yeah, it's fine. Have you still some question? No, I would like ask you, you told about aerobic stability, and can I ask you how you measure aerobic stability? Was it inside in a room with stable temperature, or?
Here it was, yes, under scientific conditions, under controlled conditions, yes.
Yeah?
Yeah.
Okay. So.
Thank you for the presentation. Can I have a question about their actually function in different types of silages? Like you mentioned coarse silage. Do they actually enhance the quality or the aerobic stability in other types of silages, maybe?
Yes, we have data for other types of silages. Unfortunately, the room here was a little bit limited to show all, but yes, we have data and we continuously generate data also for other forages. It was started in sugarcane, for example, so yes.
Thank you.
So, there is one question.
Hi, just a question on, I couldn't see the numbers on the slide, it's a bit small back here, but for the early time points that you're looking at for the early opening, what were the acetic acid levels in the treated?
By the way, all of that presented papers you can find in the internet, you can download, no problems, there's nothing to hide. You mean here?
Yeah.
Acetic acid levels here are 6.1, 7.3, 12.0.
So are they higher in the combination, or sorry, on any of the treated silages than the control?
They are higher, like control 6.1, 6.3, 8.5. So it's higher and it's also significantly higher. You can't see, but as I mentioned, you can have access to all of that papers.
So I didn't see any questions. So thank you for your presentation and answers. And now should be presentation about effect of inoculants on high moisture corn, and Professor Vrotniak. Hello.
Good day to you all. My name is Marija Dunjak, and I work at the Faculty of Agriculture at the University of Zagreb, and I will present you the results of our work regarding a homofermentative inoculant and how it changes the acid content during aeration of high moisture corn. So, excuse me. So we heard from the last lecture about the high moisture corn and how heterofermentative inoculants affect silage quality. So, but in general, high moisture corn is a silage that has a high dry matter. It's low in moisture, and because of that, the characteristic of this type of silage that you have a rather low value of acids in this type of silages. So the lactic acid is up to 2%, acetic acid is up to 0.5. Basically, all fermentation products are rather low in this type of silage. Due to this fact, this type of silage is regarded as aerobically unstable silage. So, because of that, as we heard, usually we use lactic acid bacteria inoculants to have the quality of silage that is good for the user. So, better fermentation preservation and better aerobic stability. What is a problem when we use heterofermented lactic acid bacteria? As we heard, we have a higher fermentation losses. When we use homofermentative lactic acid bacteria that mostly produce lactic acid, we will have lower fermentation losses, but we will have lower aerobic stability. So, and what is aerobic stability? It is defined as a period of time during which the temperature in the silage is not 2 degrees Celsius above the ambient temperature. That is the basic definition. Sometimes it is even 3 degrees Celsius. It depends. So, what is important for aerobic stability? We heard that is the quantity of acid. So, volatile fatty acids, acetic acid and propionic acid are really important for the aerobic stability of silages. There are multiple papers regarding aerobic stability of silages. As we heard, it is one of the most important characteristics of silage, especially because of the feed-out aeration. So, heterofermentative lactic acid bacteria are usually connected with higher aerobic stability. But what about homofermented? Is it yes or no? Usually we connected the usage of homofermentative lactic acid bacteria with lower aerobic stability of silages. So we decided to check what is happening during 1 week aeration of high moisture corn silage that is regarded as a silage type that is rather tricky to enseal. So usually you would use homofermentative lactic acid bacteria, as I said, to have lower fermentation losses. High moisture corn has a high dry matter value, so probably if you don't use inoculants, you will have higher fermentation losses because you want the fast pH drop, you want the better preservation. That you will get with the use of homofermentative inoculants. So the idea of the experiment was we used one semi-dent corn for ensealing. We had 5 repetitions of inoculated silages, 5 repetitions of control silages. We prepared silages in vacuum bags for 3 months, and after 3 months, we opened the silages. We measured the temperature automatically every 15 minutes for 1 week period, and each day we sampled the silages and did the fermentation products evaluation. Basically, the most important were the acid content, but also we determined the alcohol content. So the result, oh, this is an old presentation, okay, no problem. So the results showed that the time had effect on all parameters, on the temperature, lactic acid, acetic acid, propionic acid, methanol, and ethanol. We didn't measure the butyric acid, that is good, because it is the indicator of Clostridia activity, but we know that the Clostridia are active in moisture silage. The inoculant also had the effect on all parameters and interaction on the lactic acid, acetic acid, and methanol. So, what about the time? As I said, we measured the temperature every 15 minutes. So, what about the temperature change? As you can see, the control silage were stable throughout the whole period because the temperature difference was lower than 2 degrees Celsius. But inoculated samples, on the other hand, the 2 inoculated samples had this rise in the temperature. So we can conclude that on the 7 days, these 2 silages were becoming unstable. So, but this was on the 7 days. What about the acid change during the aeration of silages during these 7 weeks? We can see that the lactic acid was definitely higher. The inoculant is red, okay? Inoculant is red. That the inoculant, okay, I apologize, just a second. So we can see that the lactic acid was higher in inoculated sample. That is expected because we used the homofermentative lactic acid bacteria inoculant. And we saw this specific pattern of change in lactic acid, also in acetic acid, and also basically in propionic acid. That was really interesting. So we then checked if these specific patterns appears in other manuscripts. It does. So usually during aeration you have a drop and then rise in some types of high moisture samples. Let's see acetic also. So you have in control samples higher acetic acid content, also propionic acid content. That is expected. As I said, we use homofermentative inoculant. So homofermentative inoculant mostly produce lactic acid. So the lower acetic acid and propionic acid are expected in inoculated silages. And as I said, this specific pattern was seen by others. So you can see this drop and then increase in high moisture corn silage. This is from Kanibe et al. So, and also, what about the alcohol? So alcohols, we measured ethanol and methanol. We didn't measure propandiol in these silages, probably because we used homofermentative inoculant, not probably, mostly because we use homofermentative inoculant, and also because the propandiol is a result of metabolization of lactic acid towards acetic acid and propandiol. But let's go to our results. So ethanol was reduced in inoculant silages. As you can see, that is expected again because we use the homofermentative lactic acid bacteria inoculant, and also methanol was also reduced in inoculated samples. That was expected. And we saw this reduction in the alcohol content. Again, it is comparable to other results, to other manuscripts. Yeah, and what I wanted to mention, so Lactobacillus buchneri, heterofermentative inoculant, of course, is connected with higher methanol content inoculated silages because it is a heterofermentative lactic acid bacteria. When you use homofermentative, definitely you will have lower alcohol content in silages. So at the end, to conclude, at 1 week, all silages were stable except one inoculant silage, but usually we can conclude that even though that during these 7 days, or for inoculant silages 6 days, all silages were stable. This is enough period during the feed-out phase, so it shouldn't be a problem for the usage of homofermentative inoculant. So my main question for everybody is it better to use homofermentative or heterofermentative lactic acid bacteria? Because if we use homofermentative, we will have lower fermentation losses, and we see from our results that we will have stable silages for 1 week, or we want to use heterofermentative lactic acid bacteria, and to be certain that we will definitely have higher aerobic stability, because this type of inoculants will produce acetic acid and propionic acid. It is a really big question for the producers. And our experiment was a part of big trial on high moisture corn silage. This is our last manuscript regarding what is happening to the zein proteins, to be exact, to gamma zein protein, that is responsible for the connection of zein proteins in protein granules. And we know that during ensiling, zeins are degraded, and practically you have a higher availability to starch granules, and you will have a higher degradability of starch in ensealed sample compared to high moisture corn that is not ensealed. And practically we showed in this manuscript that definitely proteolytic activity of lactic acid bacteria is important for the higher degradation of zeins, to be exact, to higher starch degradability. And the producers need to be aware of that for the usage of high moisture corn in cow, in ruminants nutrition, because the higher starch availability could be a problem because of acidosis. So this is maybe a bigger picture, because I work at the Department of Animal Nutrition. So our forage production is intended, we are checking the quality of forages compared to animal nutrition. So basically that's that.
Thank you for your presentation. And now it's time for questions. Yeah, Marketa.
Thank you. I just want to comment that when you measure the aerobic stability period, if it's 6 days or 7 days, you shouldn't really think it's an absolute time in a practical farming situation, because in experimental situation it's airtight until you open it, but in the farm there is gradual.
No, because we made it that it's not airtight. So we open it and we, made it that the air is throughout the whole mass, but I agree with you, the circumstances are ideal for, it's not comparable to farm conditions, but we wanted to just to check if there is a difference when you compare the silages that were not ensealed with inoculant versus silages that were ensealed with homofermentative inoculant, because usually the usage of homofermentative lactic acid bacteria is connected with lower aerobic stability.
Yeah, I agree. It's good to compare the treatments, but the absolute numbers may be different.
Yeah, I agree. I agree.
Thank you. Still some question? I would like to ask you told something about heterofermentative and homofermentative bacteria. So when some farmer come to you and ask you, what is your suggestion for high moisture corn?
High moisture corn. It's a tricky suggestion. It's a tricky question. So basically, it's up to farmers to decide, because there is not the right answer, there is not a wrong answer. It depends about the circumstances. If you want to have a higher preservation of nutrients, then definitely you will use homofermentative, because you will have a fast pH drop, you will have a fast conservation. But if you want a higher aerobic stability, then you should use heterofermentative. So practically, maybe my advice would be use inoculant that is a combination of homofermentative and heterofermentative lactic acid bacteria, because they will, work together and produce silage that is of good quality. But again, it depends also about the quality of green material. It's a tricky question. There's not the right answer, to be exact.
Okay, thank you. If you have no questions, so thank you very much.
You're welcome.
And next presentation has Marketa Rinne, and it's about effect of additives on crimped ensiled grains. Yeah.
Thank you, and I'm here replacing Marcia Franco and Arja Seppälä, who unfortunately they couldn't join this seminar due to family and health reasons, so then it's me presenting this presentation. Okay, so now again we move to Finland with quite exotic conditions compared to most of you in very north, and so first of all the grain that we used here is not maize. We don't have maize growing in Finland, so then we are talking about barley preservation in this case, and also the harvesting conditions in the autumn are quite moist, so then we have to dry the grains for them to be stable, or use some other method, and then the crimping and ensiling is the option. But otherwise the farmers, they need to dry the grain. Here you see a grain dryer, and you can imagine it's quite a big additional cost because you have to build the dryers, and then you need to use the energy to heat and dry the grain. So then this ensiling is a low-cost option compared to that. And there are also some other benefits compared to that on top of that, and it's often rainy in the autumn, so then you are less dependent on the conditions. You can't go to harvesting grain otherwise if it's very humid, if you are aiming for drying, because it will even more increase the drying costs. Also, there's a wider window for harvesting time. You don't have to wait for the grains to mature fully, which may be also a problem because the winter is coming. So, or you can use later maturing varieties that have longer growing time, and then you can have a higher yield. And also, oftentimes, when you renew the grass, you use grain as a cover crop, so then you can harvest it earlier in the autumn and give better chance for the grass to get established. Also, this crimping can have positive effects in feeding. So it can increase the digestibility. It's already moist. When you do TMR, it's a benefit. Also, you don't have to mill it because it's already cracked. When you ensile it, you can put it directly into the TMR. So there are many practical benefits from crimping. And then, of course, the question is how to do it in the best way. Of course, you have to do good management decisions. And one possibility to improve the quality is to use additives. And then there are different qualities related to different types of additives. So the lactic acid bacteria inoculants can boost and direct the fermentation and produce acetic acid to improve the aerobic stability. Then formic acid is restricting the fermentation and the growth of harmful bacteria. And then propionic acid also protecting against aerobic deterioration. The grains can be in farm scale, ensiled in such tubes, or just in concrete silos or piles. In this particular experiment, we used 9 different treatments. We had a control without any additive. Then we had a heterofermentative lactic acid bacteria inoculant. And then we had 7 different combinations of organic acids. And they are here in the order of, let's say, efficiency. So it's the amount of undissociated organic acids. And they are coded in such a way that the F means formic acid, and then the number after that is the amount in percent of that acid in the additive. And P stands for propionic acid, and then the number again in percent, how many there were. And then the plus means that there was some additional substance there, and that was either potassium sorbate or sodium benzoate. And these were most of these were commercial products. Most of them were from Eastman company, but not all. Actually, Eastman was funding this experiment. And then we got the barley grains crimped from a commercial farmer. Sorry. This is the crimping mill type we use. This is actually not from this exact experiment, but this type of mill is used by the farmers to do this. And this is the composition of the raw material after crimping. So the moisture content was quite high, 34%, but this is quite normal in our conditions. It's actually easier to preserve it when it's rather high. If it gets drier, then you are more likely to have problems with molds and heating. The yeast and mold counts were not particularly low or high. And we did this in pilot scale silos. We mixed the additives by hand into the grains separately for each replicate, and then they were compacted in these cylindrical silos. And after 3 months of storage, they were opened and sampled. And here is just the visual appearance of the grains. They were not very severely cracked, but and not really much change during the ensiling period on the appearance. And then we get into the results. So here is pH of the samples, and always the two first ones, this is control, and then the lactic acid bacteria treatment, and there was very little difference between those treatments in any of the results that we see. And then it's these formic acid dominating additives here in the middle, and the strength, so to say, of the additive strongest here in the first one and then declining, and then the last one is poor propionic acid. So this pattern is for the next pictures as well. And it's typical that when you have more fermentation, then you have lower pH. And so when the added acids are restricting the fermentation, then you have a higher pH. But all of these were low, so even the highest one was 4.1, so that is pretty good. And then the ammonia, there was clearly more degradation of protein in the non-acid treated ones, also highish in the propionic acid one. These figures actually are corrected for the ammonia, because part of them contained ammonium formate, so then you add some ammonia in the additive, so the results are corrected for the amount added in the additive. But all these formic acid-based additives clearly restricted the protein breakdown, but the values are not particularly high for the other treatments either, so they can also be considered good. And then here is the production of, or the amount of fermentation acids in the samples. And clearly the formic acid-based additives, depending on how much acid there was a really clear dose-response effect on how much the fermentation was restricted. And again, hardly any difference between the control and the lab, so for some reason there was no response to that. And quite much lactic acid-dominated fermentation in all the silages. And here is the fermentation losses. This is the weight difference before and after the ensiling period. And not so clear pattern, but anyway, statistically, these acid-treated silages, it was less losses. And then the aerobic stability, that was, of course, it was one of our key outputs from this experiment, but we followed the samples for almost 10 days, and none of the silages heated in this method that we used. And we sometimes have this, particularly with the grain experiments. So that was, of course, sometimes it works fine, but not always. So then it would be good to have some other types of methods also to analyze the aerobic stability. And when you keep those samples in this kind of setting, you may still see that they are molded, but they start to, I don't know, they also start to dry. So then, of course, then they will become stable because of that. We have tried in some experiments different approaches like visual inspection to see if they start to mold and so on. In this particular case, with some treatments, we explored this analysis of gases produced by the, we had a bigger pile of silage. It was 3 kilos. And we put in boxes, and then we analyzed the gas. And then we saw actually quite clear differences between the treatments, which were also logical, so that both carbon dioxide and nitrous oxide, so that when control was producing more, and acid treated nothing, and then the inoculant was there in between. But here again, if you look at the time scale, this is, again, around 10 days when this started to happen. But I think this is something, it would be nice to share ideas with some of you others who are doing this type of research, what would be the good methods in studying aerobic stability. So that was results from this experiment.
Thank you for your presentation. And now, some questions. Nobody. I would like to ask you, you wrote there that aerobic stability was 2020 hours, that nothing happened. And did you measure it a longer time or not?
I think if you go over 10 days, then it doesn't really, I mean, the samples may be already spoiled and it's or dried, so it doesn't make sense to wait for longer with that method, at least. Okay, and it was also measured in laboratory in comparison with a stable temperature for the whole time? Yeah. Okay, so there is one question.
Marketa, did you expect such results in ammonia content if you add some propionic acid. It's also a surprise if you look to the composition of VOCs. Yeah? Did you expect those results?
In a way, yes, because formic acid is much more effective in restricting the fermentation during the presentation phase. So then I think it was expected.
So I didn't see any question. So thank you very much for your presentation. And now we will have the last presentation from section 1 and also the last presentation before lunch. So, Professor Weiss, please.
Hello everybody, it's the last presentation now. I will speak about the effects of partial recycled plastic, degrees thickness, number of layers, and mantle film to baled grass clover silages. It was a joint venture project between the Swedish University under the head of Elisabeth Nadeau. With her together work Frida Dahlström. She is also in the auditorium, if you have any questions after the presentation. And together with Anders Larsen from Trial World Sweden. And we have made the analysis in our lab. And Elisabeth asked me to help the presentation today because she couldn't come to Brno. That's why I'm standing here and I will give the results the good I can do that. Okay, the background. Baling is a common storage method for silage, you know that, and especially for smaller farms and also for farms complementary which have bunker silos. And for the background of climatic discussions, there is a need to decrease climate impact from stretch film production. And that's why the aim of the studies were the following things: to study the effect of decreased thickness, to look for the including proportion of recycled plastic in stretch film, to evaluate the effect of the number of stretch film layers, the mantle film replacement of net under stretch film, and all these on the effects of the technical traits of the bales, and of course the silage fermentation characteristics. And the material and methods. Grass clover was moved, wilted overnight to 32% dry matter and baled at the Lantmännen Research Farm from Viken in the southwest of Sweden with McHale, and that is a machine which could handle both net and mantle film production. And here you see the treatments. 4, 6, and 8 layers of the different stretch film from Triowrap, 19 micrometers, 25 micrometers, and another one was the loop, 25 micrometers, which contained 30% of recycled material. And in addition, net or Mandl film under TriOrep plus 19 micrometers and TriOrep 25 micrometers were used. And in contrast, only net was used under the loop treatment. What kind of measurements the colleagues has done? Of course, the bale volume, the presence of carbon dioxide, and the silage density were registered. The silage fermentation quality, all parameters which we can do in our lab, dry matter losses and aerobic stability of the silage were analyzed with the typical routine methods. The data were analyzed as a randomized block, and pairwise comparisons were done with a Turkey test. What are the results? At first, here you can see there were no effects of thickness and inclusion of recycled plastics. You see here the three, could I hold it? No, oh, excuse me, here? Here. You can see the three TriOrep and all parameters, and you see no significant differences concerning carbon dioxide, volume, density, dry matter, the fermentation parameters, pH, lactic acid, acetic, ethanol, ammonia, VSC, dry matter losses, and aerobic stability. There were no differences. A little bit other results, effect of layer of stretch film. And here you can see 6 and 8 layers of the stretch film increased the proportion of carbon dioxide in the bales compared to the 4 layers, and which shows a greater sealness, of course. But there were no differences in the dry matter losses and also in the fermentation products, which are also combined with increased carbon dioxide production. And here you see no differences. And the third, concerning the results effect of Mandl film or net. And here you can see the comparison between Mandl film and net under stretch films, and they showed a greater proportion of carbon dioxide under Mandl film, and related to the sealness of the Mandl film, and there were no differences in the fermentation parameters, but the aerobic stability tended to improve by using of Mandl film, but is also in tendency according to the statistics. And now I come to the conclusion. At first, the stretch film of 19 micrometer thickness resulted in as good sealness of the bales, silage density, and fermentation quality in comparison to the stretch film of 25 micrometers thickness, and the stretch film of 30% recycled material resulted also in a good sealness of the bales, silage density, and fermentation quality in comparison to the virgin material. The increased number of stretch film layers resulted in improved sealness, but without any effect on silage fermentation. The use of Mandl film instead of net resulted in improved sealness, greater silage density, and a tendency to greater aerobic stability without any effects on silage fermentation. And now I'm finished the presentation, and here you can see the acknowledgements, and I want to say thank you for your attention.
So, thank you for your presentation, and have somebody a question? No, I think everybody would like go to lunch, so thank you very much for your presentation and answers. And lunch should be from 1 o'clock, and next section will start at 2 o'clock. So thank you and see you there.